Topic 2, Unit 1, Properties of Addition and Multiplication. Well, there are some terms that are listed in a table, and you're assigned a few questions to sort of reinforce the concept. The basic idea here is that with commutative properties, order does not matter. The order doesn't matter. You can, in other words, if you got two numbers, doesn't matter whether you add one number before the other number, you get the same answer. Same with multiplication. If you have two numbers, it doesn't matter the order that you multiply them in. I will say, though, that the order does matter for subtraction. So that's why I really strongly suggest that you, as you're working out problems, just add numbers, because then the order that you do them in doesn't matter. But it gets really messed in your head if you start trying to subtract numbers when there's a jumble of them, like maybe 3 in a line. Just think addition of negative numbers instead of subtraction. And so now I've got a few examples to illustrate these concepts. Right, so many everyday activities are commutative. That is, the order in which they occur does not affect the outcome. So you're putting on your shirt doesn't interfere with putting on your pants. Same with putting on your pants. You could put on your pants first and then put on your shirt. They're commutative. So let's look at some examples. Putting on your shoes and putting on your socks. Well, this is not commutative because the order does matter. You do not want to be trying to put your socks on over your shoes. It just doesn't work. The order is important. Socks, then shoes. Getting dressed, taking a shower. Okay. I would say that this is not commutative because you'd want to take a shower and dry yourself before getting dressed. So again, example B is not commutative. Combing your hair, brushing your teeth. Well, who cares? Brush your teeth first, comb your hair first. Doesn't matter. This is a commutative. Well, these are commutative processes. And so the commutative property of addition is that any two real numbers can be added. You can add them in any order. Same for multiplication. You can multiply in any order. So 10 plus 30 is the same as 30 plus 10. Or 5 times 3 is the same as 3 times 5. A couple of other important things to note are identity properties. Anything plus 0 is the same thing. So in other words, 5 plus 0 is 5. Okay? And anything multiplied by 1 is the thing back. So 8 times 1 equals 8. This is a very important property. It looks kind of weird, but what we're saying is I've actually already used it. So anything divided by itself is 1. There's another way of saying that property. I guess finally here, example 8, determine the difference of temperatures. Record high temperature in the United States was 134 degrees Fahrenheit in Death Valley, California. Record low was -80 at Prospect Creek, Alaska. How much greater was the highest temperature than the lowest temperature? Well, here's how you go about doing this. You go, okay, well, the highest temperature is 134 degrees Fahrenheit, 134 degrees Fahrenheit minus, because you're trying to find the difference, the lowest temperature, which is, well, minus 80. Well, you got a double negative here. So this is the same as 134 plus 80. Force up to 214. Let's put the unit in Fahrenheit. 214 degrees Fahrenheit. It's the difference between the coldest and the hottest temperatures recorded in the United States. I just want to talk about some order of operations involving absolute value. Here, so look at this. Absolute value of 5 minus 2 plus the absolute value of 2 minus 5. Remember, absolute value signs are grouping symbols. So watch this. I'm going to write this as the absolute value. I'm going to evaluate what's inside. 5 minus 2, 5 plus negative 2 is 3, plus the absolute value. The absolute value of 2 plus negative 5, well, the absolute 2 plus negative 5 is negative 3. Well, the absolute value of 3 is 3. It's 3 units away from 0. And there's a plus sign. The absolute value of negative 3 is, well, it's also 3. It's 3 units from, negative 3 is 3 units from 0. 3 plus 3 is 6. Okay. What if I have a minus sign in there, though? What if I do this? The absolute value of 10 minus 6 minus the absolute value of 6 minus 8. Well, what's that going to be equal to? Well, I'm going to write down my grouping symbols with a negative sign in front. 10 plus negative 6. 10 plus negative 6 is 4. 6 plus negative 8 is negative 2. Well, the absolute value of 4 is 4. Then there's a minus sign. And the absolute value of negative 2 is 2. Negative 2 is 2 units away from 0. 4 minus 2 is 2.